Hello friends, so right now we are moving towards the resource management and waste management of the science exhibition which is held by CBSE, and right now we are at New Era Senior Secondary School. So let us move towards this hall. So right now they are settled in the conference hall and we would be seeing all the projects. Right now we are entering this conference hall and let's see our first project. Now at the entrance we are having a project from CBSE school of Aadharshila, and they are producing all the biodiesel, bioethanol and biogas through waste material.
Good morning. Myself Vishwa.
And myself Bhupen.
We are from Aadharshila CBSE school studying in grade 8. Nowadays, fossil fuel prices are increasing a lot.
As India is also developing very fast, the need of oil is also increased.
And to fulfill this need, we are dependent on other countries.
In the developing race, we need to become independent in all aspects.
And we are trying to be independent or less dependent to fulfill this need.
As India is also a very populated country, we produce various kinds of waste.
From this waste, we have produced fuels.
That is nothing but biofuel.
And we have different kinds of waste like cellulosic waste, fatty waste and starchy waste. And we are suggesting 3 models under one roof.
So now let's move on to our first unit, which is biodiesel production. For this, we have collected fatty waste like used cooking oil from various restaurants, hotels and our homes. After collecting it, we have filtered it using a filter because it may contain some solid impurities. After filtering it, we have heated it at 70 degrees Celsius because it may contain some water molecules which will later turn the oil into soap, which is known as saponification. After heating it, we have to let it cool down for some time. After cooling it down, we have transferred it into this stirrer tank where we have added some potassium methoxide, which we have made after adding 2 grams of KOH and 40 ml of methanol.
After that, we have to stir it for 20 minutes. And after stirring it, we have to transfer it into the settling tank and leave it for some time. After some time, we can see 2 layers. The upper layer with the biodiesel and the bottom layer with the glycerin, which is the byproduct of the biodiesel, which can be further used for soap making industries. And biodiesel can be used in the replacement of natural diesel without modifying the engine. And we have checked at different temperatures, but 70 degrees Celsius is the best for high production of biodiesel.
So now let's move on to our second unit, which is bioethanol production. For this, we have collected sugary and starchy waste, which we have made into slurry after adding some water, and Saccharomyces cerevisiae, which is yeast. After making a slurry of it, we have to let it sit for some days. After some days, you will see that there will be 2 layers formed. The upper layer will be fermented liquid and the lower layer will be solid waste.
After that, we will transfer the fermented liquid into this container and then into this heater tank, and we have heated it. And the ethanol vapor will go through this fractionating column which contain marbles in it. We have put marbles because if the water vapor will come along with the ethanol vapor, it will stick to the marbles and settle down back at the heater tank, and only ethanol vapor will go through this pipe and this condenser, and this process is called fractional distillation. And this condenser contains cold water in it. We have put cold water because if the ethanol vapor will convert into the liquid and we can collect into this container. And ethanol can be blended with 10 to 20% for the petrol for long lasting use and for the vehicles. And we have checked 2 bacteria. First, Saccharomyces cerevisiae and Xynomonas mobilis. The Saccharomyces cerevisiae is best for high yield of production of bioethanol, and it is resistant for the high concentration of bioethanol.
Third unit, which is biogas production. For this, we can use the solid waste produced in the bioethanol unit along with some cellulosic waste. We have made a slurry of all this waste along with some water and some cow dung because the cow dung contains some methogenous bacteria in it. After making a slurry of it, we have to let it sit for some weeks. Now let's move on to a third unit, which is biogas production. For this, we can use the solid waste produced in the bioethanol unit along with some cellulosic waste which we have made into slurry after adding some water along with some cow dung because the cow dung contains some methogenous bacteria in it. After making a slurry of it, we have to let it sit for some weeks.
Methogenous bacteria digests the cellulosic waste and produce methane gas, which we can collect in this gas holder and which we can use with this outlet. And waste generated from our project can be used as a production for biogas production, and waste generated from this product can be used as a manure agriculture field for the high yield of crops.
Thank you.
So right now we would be visiting the mathematical modeling and computational thinking sub-theme of this science exhibition. So let's enter. So friends, right now we are going to visit transport and communication sub-theme.
Judges, can I have you please?
नहीं